Okay, hi everyone. For today, we will discuss more on the network scalability. We know already how to provide high ability connection to your network in various condition. But now we look into how can we scale the network and why we need to scale the network. Because nowadays, uh, there are many requests or many requirement or different type of requirement for different type of user, and maybe you will work with very dynamic in organization which they require to scale their service, and then the user also very dynamic. They have changed the numbers of users, the numbers of application, and other business change as well. So we need to know how to scale the network. Scale mean scale up and scale down. That means you can dynamically expand and scale it down to ensure that your network uh, fulfill the requirement of the user. Sometimes the organization require a very large amount of bandwidth to cater very specific application. Sometimes they require only a minimum number of bandwidth or minimum server that they need to deploy. Depend on the situation. Like I mentioned before, if let's say e-commerce system, they not necessarily having a huge number of server every time, only for specific or peak hour, for example, or peak time during the promotion and so on. But in normal time, they just require, for example, 50% of the uh, bandwidth requirement and also the server requirement. Okay, you see here one of the hierarchical network design for this scale in and scale out the network. So here, organization is increasingly rely on their network infrastructure to provide mission critical service. That means the service that highly um, affect their business, their mission critical. If their mission critical service is not function, then their core business will be not function, cannot be operate, then they will lose. So evolving organizations require network that can scale and support in terms of converged network traffic. That means combination of multiple type of network traffic, not only the video, audio, voice over IP, text, chat, and many more. Lot of network traffic type. And then about the critical application. Normally critical application, they require very high availability connection. When they want to access it, must be there, available. Available in terms of connection, in terms of uptime of the server. All the component must be available. The support component, the physical infrastructure also must be on, must be ready for their critical application. Because sometimes the critical application itself requires specific bandwidth. For example, if they are running uh, simulation or they are running online game, the bandwidth must be uh, higher or bigger than others, right? They have the specific bandwidth requirement. Also, when you see there are certain condition they did not cannot compromise for any latency or any error bits. This is critical application. And then diverse business needs. Nowadays, one company or organization, they will involve multiple type of business needs. Maybe their client having different type of traffic, different type of application they will use. Their staff, HR, finance, what they need to connect to multiple type of application. Maybe not in their premise, in other servers, in other site, in other cloud environment, they need to get the diverse business need. especially when they need to comply with a specific standard, like we discussed about ISO 27001, ISMS, SOC, PCI-DSS, HIPAA, and many more. So this type of compliance standard also require different type of tools to be implemented in order to support and to comply with this requirement. And then centralized administrative tools. So we learn about CM, network monitoring tools, network management tools, centralized administration. So nowadays we have software-defined network, software-defined data center, software-defined access, all the software, right? So we need to support, our network must support this type of tools, because these tools normally will be in web-based or web portal format, mobile apps format, and then this type of administrative tools also must support several type of data, like MIB, management information base, other control flow, net flow. There are some log, right? Must be able to get and analyze, correlate this type of data in order to give you better visibility in your management console. So this one also require a specific requirement, a specific network requirement. Okay. So campus network design includes small network that use a single LAN, reach up to very large network with thousands of connection. Okay. It's not necessarily you have a single one, but most of the time now we have more and more connection requirement. Okay, this is just example. 3-tier and 2-tier example. We discussed earlier about the 3-tier, right? As hierarchical based core, distribution, and access. This is example. But for 2-tier, use when separate distribution and core layer is not required. Just having they collapse together, the distribution and core. So that only access layer in a single layer. This is useful for smaller campus location or in a campus site consisting of a single building, also known as collapsed core network design. Depend on your organization, topology and requirement. Is it as a switch? Okay, now we'll look at the scalable network requirement. This is for design purpose. Scalability is the term for a network that can grow without losing availability and reliability. This is the main point when we talk about the scalability of your network. You are focusing on network, that means still manageable. If you focus more on different type of component, like your data center itself have a lot of component, you will see a lot more. You need to make it scalable, but this one more on the network layer. So you didn't care about the software, the application, the database, right? The server itself, but more on your network device and network connectivity. Okay, network designer must develop strategies to enable the network to be available and to scale effectively and easily. We discussed earlier how we can have enough redundant. Don't too much redundant, but enough redundant component, and also we can eliminate single point of failure. At the same time, you need to develop a strategy to enable this scalability. Nowadays they have modular based component, so you can just put stack by stack if you require additional devices to scatter your user. Okay, this accomplished using redundancy, like I said before, redundant components, redundant devices, okay. And then multiple links, the link itself, the connection between device, connection to the internet as well, the link, okay, you need like a redundant link, multiple link. So if one of the link fail, you still have another link to be used. If you still remember your last lab, right? You're setting up the HSRP. In your HSRP, you have multiple device, multiple router. At the same time, you have multiple link, right? VLAN 1 to router 1, VLAN 2 to router 3, for example. And then both router will connect to router 2, if you still remember the design. And then we are creating a virtual network or virtual gateway for VLAN 1 and VLAN 2, and then they just using a logical gateway which using HSRP. So that two link actually combined together to become one logical link. However, they still exist two link. If one of the link fail, another link still can be used. That enough redundant. And then scalable routing protocol, like we use the XRP and other routing protocol. You learn it in your CIS 3202, correct? And then other than that, you can use wireless connectivity as part of your scalable design or your scalable approach. Because, you know, when you have the switch, they are limited, right? 24 or 48 port of switch. When you having a lot more user, you need to buy a new switch and put it in uh, modular manner or hierarchical manner. It depends on you. However, with wireless connectivity, they will offer you more flexibility. That means when you attach one of the port to your wireless access point, actually you can expand more user. Similarly, like our campus, right? We cannot afford to have the port in our wall to all of students. Like nowadays, we assume we have 5,000 students. How can we afford to buy devices that support 5,000 port for each student and then assign them in the wall, connect the switch to the wall, and we have to do a physical infrastructure upgrade also. It's not easy, not feasible, not practical enough. So we can do wireless part. So we just maybe deploy uh, 10 or 15 wireless access point throughout the building in one uh, area or in one academic building. Then we can expand the user. At the same time, user also will have a more flexible, so they can move anywhere within the campus without need to attach or bring the cable, right? With the roaming capability, they can do, you can continuously connect throughout the campus. This is one of the approach to scale your user based on the numbers of user, right? Wireless connectivity. Nowadays, we do it, right? If bring your own device policy is good to have wireless connectivity. So first, actually, we did a plan. We need to plan for your redundancy. Is one of the scalability approach, right, or technique. So redundancy can prevent disruption of network service by minimizing the possibility of a single point of failure. This is what you want to eliminate, right? How to do it? We need to install duplicate equipment. I said before, you need, for example, if inside the equipment itself, maybe you can have a component, but now you can install duplicate equipment. You need, or maybe one switch, but you have another switch, two switch. So that switch can help you, or that switch or router can help you in uh, minimizing single point of failure. Then you can provide failover service for critical devices. Our HSRP, actually we are providing failover service. That's why the 3 second, 10 second, you still remember how when you eliminate the connection, the cable, right? They require some time to fail over. That's in they analyze which router uh, can take over the failed router one. So this is providing failover service. If you require this for your critical service, then please provide it. Especially when you are hosting critical application. You have specific application that you want them to run in high availability time, then you need to do this failover. That's why most of the server they have more than one network interface card, so that they can do a failover. And each network interface card connect to different switch, for example. So redundant path offer alternate physical path for data traverse to the network supporting high availability. However, redundant path in an Ethernet network may cause logical layer to loop. That's why we're using STP, spanning tree protocol, to eliminate this loop. Okay. And then in order to provide a good scalable network, we can reduce the failure domain size. How to do this? You see, a well-designed network control traffic and limit the size of failure domain. For example, the area of network that impact when the network experience problem. So we have our network with different subnet, different VLAN, for example. Then we need to design when anything happen to one of the component, one of the VLAN, for example, is not affect other network traffic, other network subnet, the network local area network. Okay. In hierarchical design model, failure domain are terminated at the distribution layer, so that you have access. Each access, for example, one of the switch managing 2 or 3 VLAN. Then you have multiple switch. So if one of the switch fail, another switch still can serve other VLAN. Every router function as gateway for limited number of access layer user. If let's say one of the router fail, they didn't affect other router. Router or multi-layer switch are usually deployed in pair in configuration referred to building, departmental, switch block, and so on. So each switch block is independent of each other. So as a result, the failure of single device and across the network go down. So this is basic idea. Failure domain only affect the specific single device. And then other approach, actually this is also important approach when you want to have a scalable network. You need to increase the bandwidth. Okay, so that you can use link aggregation ether channel. We learned about two type, right? Port and also link aggregation last time. Allow an administrator to increase the amount of bandwidth between devices by creating one logical link made up of several physical links. He did it before ether channel, correct? So for example, one port has 100 megabit or 1 gig. Then we combine together 8 port become one logical link, then we can have time 8. 800 meg, or if gigabit, we can get at we can have maximum 8 gigabit on one single link. Okay. Most configuration tasks are done at the port channel interface instead of each individual port. So the user just using the channel interface, that's mean the logical one, to ensure configuration consistent on the link. So if the channel can load balance between the link. Although there are, for example, 600 megabit per second load, but they will share together with 8 port, for example. That's a workload. So this is one of it, I said before. Expand the access layer by having wireless local area network. This is more popular nowadays, right? And most of the um, established company like IBM, Google, they are working uh, in mobile. Although inside their own environment, their own office building, but they still can moving, right, to the cafe. They work in different, but they didn't strict that they need only working at their workstation. They can bring their laptop to the cafe, to the pantry, to the client space. So this require portable network like wireless LAN. Nowadays, this is a popular working environment. So this wireless LAN also provide the flexibility, increase flexibility, reduce costs, because you didn't require to port to physically invest for the network uh, wall in the wall, right? Network port in the wall, uh, in terms of cabling also. And the ability to grow and adapt to changing network and business requirement. So this wireless access point work with this particular technique. To communicate wirelessly, and device require a wireless network interface card. Nowadays, no issue lah, right? Most of our device equipped with NIC, not only your laptop, but your phone, smartphone, your tablet. And nowadays, most of IoT device, your CCTV, also equipped with wireless, right? Your TV, television also equipped with wireless network interface card, so that easy for you to connect to your wireless access point. However, there are some consideration you need to take into account before you implement the wireless network, which include type of wireless device connecting to your wireless line. You need to consider it. Is it only personal one, or only office own device, or your device has a specific operating system? So you need to look into it, because if you just open, maybe some of your user connect to the IoT part, or devices that didn't have enough security in place, especially the mobile base, right? They didn't equip with, for example, uh, support of authentication, support of encryption capability. So you need to look into it. Wireless device connecting to your wireless LAN, you need to specify in your um, normally in security policy, IT security policy. And then wireless coverage requirement. Is it you need to have to cover the signal until end of your perimeter, or just a specific space only? You need to look into it, because if you cover more than your perimeter, maybe outsider can access it. They have a lot of tools to get the access. Although you have uh, implement a good authentication and authorization technique. So you try to look at the coverage, then you deploy specific wireless access point based on their support or their capability. How big the perimeter is? It 100 meg, 100 meter, 50 meter, and then how many device it can support. Wireless access point, not your wireless router inside, same like in your home base wireless router. This is more on enterprise level wireless access point, which support better connection and also better numbers of user. Also the security features. And that's about the interference consideration. When you want to uh, place your wireless AP, you need to look into this. Interference mean there are some devices or some uh, equipment that will interfere, give you radio frequency interference. It look like the microwave. Don't put nearby the microwave. The another thing like leaf, right? Don't put your wireless access point nearby the leaf because they have some signal interference, right? Radio frequency interference. You need to look into it. What type of device with the signal interference? Okay, and then about the security consideration, like I said before, the wireless AP also must use the enterprise level one, which support your authentication method. For example, if you are using enterprise WPA2 enterprise, which means you need access to access the AAA server. You need to have support of Active Directory, for example. Then you must look into specific wireless access point device that can support that. Also with other network device, your wireless access point can be connected and supported by your existing switch and so on. So you try to look at in terms of security, support, and many more. Other than that, security also cover the device and device. Is it your user and device having enough security measure or security support or security features like authentication method, and then the policy, is it you are allowing their personal devices to be connected? How about the organization data? Is it the confidential data can be stored in their mobile phone or not? If let's say you are supplying the device to the user, anything happen to the device, how can you mitigate it? How can you wipe the data, delete data remotely, and many more? There are many consideration in wireless network. Okay, I think that's all for this part. I will continue back with another part later.